Okay, here's an example of using the Newton-Raphson method. So we have a function f of x cubed minus 6x squared plus 12x minus 11. It's got one root alpha, and we want to show that alpha lies between x equals 3 and x equals 4. That first bit is change of sign, so just reminding you of that. So you plug in 3, and that gives you minus 2, which is less than 0. And then you plug in 4, and that gives you 5, which is bigger than 0. And then you need to just write in the change of sign. Implies alpha lies between x equals 3 and x equals 4. Next bit, you want to use the Newton-Raphson method twice with a starting value of x1. So it's normally x0, but you might see it's x1 sometimes, equals 3.5 to find two further approximations for the root. Newton-Raphson iterative formula is there. So I need to differentiate f of x. So some things obviously a little bit harder to differentiate than others. One thing about the Newton-Raphson method, it does rely on you being able to differentiate the function that you're using. So from there, I can set up my formula. So xn plus 1 is xn minus f of xn all over the gradient at xn, so it's 3 times xn squared minus 12 times xn plus 12. And then the first thing you need to do is substitute in 3.5. I'm going to backtrack what I just said actually on my last video, and you can just use your calculator there, and I can't see why you shouldn't. So we know that the first value is 3.5. That will always be given to you. You don't have to choose that. The second one is what you get when you feed 3.5 in through here. But you really could just do this on a calculator. So same as what we did on Tuesday, you press 3.5 in and press equals. So that's now storing that as the answer. Just put it in carefully. So it's answer minus, and then I've got a fraction, so it's answer cubed minus 6 times answer squared plus 12 times answer minus 11 all over 3 times answer squared minus 12 times answer plus 12. And then your first one comes out as being 31 over 9. And really, we're sort of lending ourselves to decimals here. So that's 3.4 recurring. Just write it as that. And then, if you were doing this complete by hand, you'd put that in through there to get x3. But because we've set it up on the calculator, I can just press equals, and you get 3.442. And then if you wanted the next one along, you just press equals, and so on. So they're the next two values, but do show this bit quite clearly. And the very end of that question, which I might just do as well, just to remind you, was, oh, I forgot what it said, sorry. Yeah, we just want to show your answers correct to 3 sig fig. So if it's correct 3 sig fig, then alpha is 3.44. And this, again, this is change of sign. So you need to go either side of here and think about what would round to 3.44. So you do f of 3.435. I'll leave you to work that out. It comes out as negative. And you do f of 3.445. And that comes out positive. So these little bits are change of sign. So change of sign implies alpha lies in, and then interval notation. And if alpha is between 3.435 and 3.445, then alpha equals 3.4423 sig fig. And then the only other thing I need to talk about is when this method fails. So that's going to be the next video.